physics lessons, I just have a request to all of you that since this is a corona pandemic situation, just stay safe, okay? If there is no need, don't go outside of your home, okay? With yourself, keep others safe, okay? Now let's move towards the lessons. Okay, in class 9, you actually have 5 lessons of physics, and those lessons are like that. Our first lesson is going to be motion, okay? And second lesson is going to be our forces and laws of motion, okay? And the third lesson is going to be work and energy, okay? And fourth lesson is going to be gravitation, and the fifth lesson is going to be sound. Maybe in this case work and energy and gravitation, maybe the positions are changed. Maybe gravitation is the third lesson and work and energy is the fourth lesson. It doesn't actually matter. We have to discuss all those 4 lessons, okay, step by step. Before discussing the 5 steps, first our lesson is going to be forces, not the forces, the motion, only the motion lesson, okay? The motion lesson and the forces and laws of motion they are actually related to each other. First, we have to clear our concept about the word motion, right? So our first lesson is going to be motion. Okay, see, that word motion is not new to us. Okay, we always have heard that word motion. Okay, but in physics we have to discuss it little bit in physics way. Okay, so there are going to be some mathematics with the formulas, right? So though we have heard that word linguistically, now we have to discuss that word motion, how it is related with physics. Okay, see, in our day-to-day life we always observe particles in motion, right? See, first now consider me standing here. If now I am standing here, if I move from this position to this position, that means what? For a certain moment of time I was in actually motion, right? That means what? The definition of motion, that how can we give the definition of motion? We can say that the change in position of an object from one position to the other, okay, is known as motion, right? It means what? We can give, or we can say that change in position, okay, of an object from one position to the other, right? That means what? If I am now standing here, if I said that if I move from this position to that position, that means what? For that time I was in motion, right? See, for example, for the example of the motion, lots of examples that you can actually give. Na? A moving car, the birds flying, fish swimming in the pond, right? Players running in a field, okay? So those are all of motion, okay? See, since now we are dealing with physics, okay, we have to know the why of something, right? That means what? Since we are not grown up, okay, we all are matured now. Since you are in class 9, that means what? You have some thinking capacity, you have some imagination capacity, right? So in physics, you need some kind of imagination capacity, okay? See, there's one question that we always observe, that sun is rising in east, setting in the west, okay? That means what? We can clearly see that it is completely related with motion, but motion of what? Okay? We always consider that sun is in rest, okay, and the earth is moving around the sun. But actually, it's not sun is in rest. Sun is also moving, but for you, okay, at this certain time of or this certain moment, we don't need the motion of sun, okay. We need the motion of earth, right? See, the reason or the answer is the earth is continuously moving from west to east. That's why we always observe that the sun is rising in the east and setting in the west. So that is completely motion, right? So again, there is another question. If earth is continuously moving, why can't we actually feel the motion of an earth? What do you think? Just take 2 minutes and just think. It is completely obvious, na? Since if you are sitting in a car, okay, you can feel the motion. If it is obviously moving in a little amount of or little speed, like 10 km per hour. If the car is moving at 10 km per hour, or you can say that just forget the word kilometer. If it's moving very slowly, then you can feel it. If a train is moving very slowly, we can again feel it, right? But in case of earth, if we consider that Earth is moving at a speed of 5 centimeter per hour, okay, just considering it that Earth is moving at a speed of 5 centimeter per hour. It's a quite slow speed, no? But we should have feel that, but we can't feel it. Why? What can be the reason? Have you ever thought that, or have you ever wondered about that? But now we have to think about those things. Okay, the answer is with Earth. Okay, we are actually moving at the same speed. Okay, that's why we can't actually feel the motion of an Earth. Okay, see, consider this two as a car. Okay, if that car is moving at a 20 km per hour, and if that car is moving at 20 km per hour, that means what? These two cars is moving at a constant speed or similar speed. So for that movement, okay, the boys standing here or sitting here and the boys sitting here, they will observe each other. Okay, and for them, they are at standing position or in the rest position, though they are moving. Okay, if you can imagine it, you can actually understand it. Okay, this is all about motion. Again, we are discussing about motion. So there are actually three types of motion that we have to actually discuss, right? The first motion is going to be linear motion. Okay, or you can say motion in a straight line. Second is circulatory motion, or if a particle or if an object moves in a circular path, that is a circulatory motion. And the third is oscillatory motion. Okay, oscillatory motion. That means if you consider a pendulum, okay, if this is a pendulum, in the pendulum what happens? At a certain moment, it will be here, again it will here. That means what? First it will go here, then after it goes here. That means what? This kind of oscillating thing, na? That is the oscillatory motion. Okay, but in class 9 we need only these two portions. Maximum we have to discuss about linear motion, and in the end of that lesson you are going to have a little bit of circulatory motion. Okay, these are the mainly three things that we have to discuss with motion. Okay, now we will move towards some physical quantities that we have to discuss, that is going to be needed when we are discussing about motion, right? Wait, so have you ever heard about the terms like vector quantity, scalar quantity? No, na? See, physical quantities. Okay, in case of motion we are going to need two kinds of physical quantities. First is going to be scalar quantity. Okay, scalar quantity. Scalar quantity is those quantity where we are going to only discuss about the magnitude. Okay, see, it is that quantity which only deals with what? Magnitude. Which only deals with magnitude. Now the question is, what is magnitude? Okay, you have to understand the word magnitude. What is magnitude? Right? Magnitude is the reading of, okay, any physical quantity. Okay, see, I am almost 5 feet 8. Okay, that is my magnitude. Okay, again, if I say a car, consider a car, this is a car. If that car is moving, if I say that car is moving at a speed of 50 km per hour, okay, I have only mentioned the magnitude. Okay, this is the magnitude. Have I mentioned that that car is moving at a speed of 50 km per hour in the east direction? No, na. Okay, once I mention this direction, it is not going to be only a scalar quantity, it is going to be a vector quantity, and that is going to be our second quantity. Okay, our second quantity is going to be vector quantity. Okay, we can say, or we can write that it is the quantity which deals with both magnitude and direction. Okay, both magnitude and direction. So why I am actually discussing the scalar and vector? See, we are going to discuss in this motion lesson two terms. Okay, one is going to be speed, okay, and another is going to be velocity. Okay, so one among between these two, speed and velocity, one is a scalar quantity and another one is a vector quantity. Okay, when we will discuss about the actually uniform and non-uniform motion, okay, and the rate of motion and the measurement of rate of motion, then we will discuss about speed and velocity. Okay, now we will move towards next topic actually, that is going to be motion along a what? Motion along a straight line. Okay, motion along a straight line. Okay, straight line means what? Straight path. If we are consider straight path, that is the straight line. Okay, for that we are going to need two terms. Okay, one term is going to be distance. Okay, and the second part is going to be what? Displacement. Okay, these are the two basic terms that we are actually will deal with. Understood? These are the two terms that we have to actually deal with. Now, first we have to check what is actually distance is. Distance is nothing but that the journey, not actually journey, the total path, actually the total path covered by an object, okay, throughout its journey is called distance, right? This is the distance. Now the second property of distance will be, see, we have discussed about scalar quantity and vector quantity, right? Scalar quantity is what? That which quantity only deals with magnitude. Distance only deals with magnitude. Okay, you will observe it actually that distance is only deals with magnitude. That's why distance is a what? Distance is a scalar quantity. Okay. Again, one more property is distance is always positive and can't be zero. Okay. If we measure a distance from one position to the other, it will always be positive. Okay. We will never get distance at negative. Okay, and distance cannot be zero because it's a total path distance. Now, if it is not moving from one position to the other, it is not going to have any distance. Okay, so if I use the word distance, that means what? That particle or that object have to move from one position to the other. That means what? It cannot have a zero value. Understood? This is the properties of distance. Now we have to move towards the displacement. The displacement is, it is the shortest distance between initial and final position. Okay, displacement is the shortest distance between initial and final position. Okay, consider this is the initial point now and this is the final position. Okay, the shortest distance between that initial position and the final position is displacement. Okay, you have understood this. Okay, now the second property is, we have also discussed about vector quantity. What is vector quantity? Vector quantity is that quantity which only deals with what? Direction as well as magnitude. Displacement is like that. Displacement both actually deals with both direction and magnitude. That's why we can say that displacement is factor quantity. Okay, displacement is a factor quantity. Again, displacement is, or not is actually, can be positive, okay, negative, and can have zero value. Okay, can have zero value. So these are basically some properties, or you can say some differences about distance and displacement. Okay, you can actually look closely and you can actually write if you want. Just write this down. Okay, motion along a straight line, the displacement and the distance, and some properties about distance and displacement. If you want, you can actually write it down. Okay, now we will consider an example actually to understand this properly. Okay, how motion in a straight line can actually be shown with an example. Okay, just wait for a minute. I will first erase this. Now I will show. Okay, since we are actually dealing with a straight line, first I will draw one straight line. Though it is not a proper straight line, just consider this as a proper straight line. Okay, now I will give some readings. Okay, consider this is a straight path where I will have some readings, and those readings will be in kilometers. Okay, now I will consider that this is my starting position. That's why I will give this name as A, or it will have some reading O. Then I will give a reading 10 kilometers, 20 kilometers, 30 kilometers, 40 kilometers, 50 kilometers, 60 kilometers, 70 kilometers, and 80 kilometers. Okay, I will give these readings as like that. Now I will consider that some actually positions like B position, C position, and D position. Okay, now first I will consider that a car actually here first, then it will move to B position. Now it will move to the D position. Okay, now first we will actually see distances. Okay, I will first erase this thing. Okay, I will consider that the car was first here, then here, after that it was in D position, right? First I will actually observe the distance. What is the distance? Now first, the distance from A to B is how much? From A to B is how much? 30 kilometers. It's quite simple. Reading is 30, that means what? The distance is in 30 kilometers. Now from B to D, distance is how much? 30 to 80, that means what? 50 kilometers. Okay. Now as a whole, from A to D position, the distance is how much? 50 plus 30 equal to 80 kilometers. Okay, understood this one? Now we will see about displacement. Okay, displacement. To understand the displacement, okay, first I will consider that the car has moved from A position to direct D position. Okay, A position to D position. Okay, here what will be the displacement? What do you mean? What can be the displacement? See, when I was given you the displacement, the definition of displacement, it was the displacement that the shortest distance between initial position and the final position. Here the initial position is A and the final position is D. Now the shortest distance between, how we have to find the shortest distance? We just have to subtract DA, right? We will subtract 80, and this is the reading, this is the reading of 0, that means 0 equal to how much? 80 kilometers, right? Okay, again just come back to distance. What if that car move from A to D 80 kilometers? What if it again move from D to A? How much distance it will travel actually? From 0 to 80, okay, again from 80 to 0. So total distance from A to A will be how much? 80 plus 80 kilometers equal to 160 kilometers. But if I consider in case of a displacement that displacement has done from A position to A position, what do you think? Is it going to be 160 kilometers or no? No, definitely not, because displacement has a definition like that it is the shortest distance between initial position and final position. In this case, A to A, what happened? The initial position was A, right? Again, since it has moved from A position to D position and D to A, that means what? The final position again become what? A. Okay, so displacement D is equal to what? A minus A. A has a reading 0 again, so we can write 0 minus 0 equal to 0 kilometer. So that we have written now that displacement can be 0. So this is the proof. And distance cannot be 0. This is the proof. Again, what we have saw that distance is not equal to displacement, right? Okay. So the concept of distance and displacement actually satisfying with this example, right? I think you've understood this now. So this is the main thing about motion along a straight line, and there's a main thing about displacement. Okay, understood? Okay, till now we have discussed lots of things about this lesson motion, no? Where we have discussed about distance, displacement, right? Scalar quantity, vector quantity. Okay, we have saw some examples of scalar quantity and vector quantity. Some examples like what? The examples of scalar quantity is distance, and the vector quantity was displacement. Now with this example, we have understood the thing about displacement and distance, right? So these are some of the basic things about this lesson. Okay, so in the next part of this video, we will actually move towards the later part where we are going to solve some problems, okay, related to the motion. Okay, for that, just subscribe to the channel. Okay, then you are going to get some kind of notification once I upload the next video. Okay, but till then, as I said in the earlier part, just stay safe, stay in home, don't go outside, please, not needed. Okay, stay home, do your studies. Okay, have some fun in your home. Okay, and spend time with your family. Okay, till then, stay safe, bye bye.